Robert needs to cut 4 shelves from a board that is 2.5 meters long. Notice this is 2.5 meters long. The second shelf is 18 centimeters longer than twice the length of the first shelf. So there's your clue. Now notice this is in centimeters. Alright. The third shelf is 12 centimeters shorter than the first shelf. The remaining shelf, which is the fourth shelf, is 4 centimeters longer than the first shelf. If Robert must use the entire 2.5 meter board for the shelves, what is the length of the second shelf? So this is the question we have to answer in centimeters. Now the first thing we're going to do is we're going to establish the equations for our shelves, or not equations, our expressions. Shelf number 1 we're going to let equal x. Now shelf number 2 is 18 centimeters longer than twice the first one. And then the third shelf is 12 centimeters shorter, so that's going to be x minus 12. And then finally, the last shelf is 4 centimeters longer than the first shelf. Now that we have these 4 boards established, what we do know is that if I were to add all of these together, they would add up to 2.5 meters long. So we need to convert this 2.5 meters to centimeters. Now remember, 2.5 meters times 100 is going to give me 250 centimeters. Okay? So now we're going to use 250 centimeters instead of 2.5 meters. Alright, so if I were to take all of these components, if I were to take x plus 18 plus 2x plus x minus 12 plus x plus 4, if I were to add all 4 of those shelves together, this is shelf number 1, 2, 3, and 4. If I add them all together, they would add up to 250 centimeters. Now, if I were to add like terms, what I end up getting is x plus 2x plus x plus x adds up to 5x. Then, if I add up the numbers, 18 minus 12 and plus 4 is going to add up to 10, so plus 10. And that, when I add those all up, again, they're going to add up to 250. Now I have a two-step equation. I'm going to subtract 10 from both sides. I end up getting 5x equals 240. Divide by 5, and x is equal to 48. Now, that is the length of the first board. But that's not the question I want to answer. I want to know how long is the second board. So I'm going to plug in 48 for x. So 18 plus 2 times 48 gives me 18 plus 96, which is equivalent to 114 centimeters. Now, if you wanted to, since you now know what x is, you could actually plug that in and find shelf number 3 and shelf number 4. Okay, in problem number 2, Tito solved this equation. 2 times 3x plus 5 equals 22 plus 5x minus 3x. Now, in the first line, what we want to do is we're going to find out which of the following properties did he use, and we're going to check all that apply. Now, in line number 1, we obviously see that he used the distributive property, so we're going to go ahead and check that off. And then here, we combine like terms. In the next line, notice we cleaned it up, and then we subtracted 2x. Now remember, subtracting 2x is just like adding the opposite. So I could have also had added a negative 2x. In some levels, subtracting and adding the opposite could be construed, they're the same thing, but if I were to use this one, I would have used the addition property of equality. So we're going to go ahead and say that we went ahead and used the addition property of equality. Now, what I'm left with is 4x plus 10 equals 22. We're going to subtract the 10 on both sides. Now, remember, this is just like adding a negative 10. So again, we're using the addition property of equality if we use it in this format. We don't have the subtraction property of equality, so I'm not going to apply that here. Now, on this next level, when we clean this up, when we subtract 10 from both sides, we're left with 4x equals 12. That's this level right here. Now, in 4x equals 12, notice that they divided both sides by 4. Well, another option is to multiply by the reciprocal. And if I multiply by the reciprocal, that leaves me with x equals 3, which is the same answer that they got. Now, if I use this method, that is definitely the multiplication property of equality. So remember, dividing and multiplying are inverses of each other, and on some level you can actually call this the multiplication property of equality, and the subtracting of the 2x and subtracting of the 10 can also be called an addition property of equality, because you could also add the inverse or add the opposite of those numbers. In problem number 3, Aileen can read 1.5 pages for every page her friend can read. Aileen's mom was very excited and she said to Aileen, "So if your friend reads 20 pages, you can read 25 in the same time period." Is Aileen's mom correct? Well, let's go ahead and establish some, let's get some math done. We know that each page is equal to x, okay? And Aileen can read 1.5 pages for every page that her friend can read. Well, if I were to plug in 20, as her mom states right here, 1.5 times 20 is actually 30. So Aileen could read 30 pages in the same time that it takes her friend to read 20 pages. So is her mom correct? Well, the answer is no, so we can mark out A. But let's look at the other answers. All of the answers have no, Aileen's mom is incorrect. So it's possible that all three could be the right answer. But if you look at the rest, Aileen can read 27.5, Aileen can read 30, and Aileen can read 40 pages. The only one that makes sense or that corresponds to our work is C. So you can eliminate B and D. And that right there is the correct answer. In problem number 4, Jabari owns 100 shares of stock A and 45 shares of stock B. For the past month, his stocks have been fluctuating inversely each week. Stock A decreased by M cents per share, and stock B increased by N cents per share. Which equation can be used to find the total change in value of Jabari's shares? Well, first of all, we have two stocks. We have A and we have B. Now, notice that all the answers have V for the answer. So that means that's value. So we're going to talk about his value. Now, we know in stock A, he has 100 of them. But it says stock A decreases by. When you see the word by, that implies multiplying. So M cents per share. And because they're decreasing, that means they are negative. Well, if you have 100 shares and you multiply each one of them by a negative M, which corresponds to decreased by M cents per share, and then you also have your stock B, and you have 45 of them, but they are increasing by N cents. So again, the word by implies multiplying. So we're going to multiply each of those 45 shares times a positive N. Well, what we have to do is we're going to add those two stocks together. And in doing so, the only one that looks like our equation is A. Now, how is B not the answer? Well, B shows that the stock B is decreasing and stock A is increasing, and that is incorrect. If you notice in C, C shows that the decrease is being multiplied by 4. Well, there's no 4 in the problem. Okay, so we can go ahead and eliminate that. And then here, what they did was they added the 100 plus the 45, and then multiplied the decrease times the increase. Well, that is not correct because it shows that the decrease was times the 100 and the increase was times the 45, so therefore D is not the answer either. Okay, and number 5, an entertainment firm offers several DJ choices and light shows that range in price based on the rental time period. The DJ costs between $219 and $369 per night, and the light show costs between $159 and $309 per night. If you are booking both a DJ and a light show, write a compound inequality that represents the total amount you would pay. Well, in this particular instance, it always helps to write down your information. So in this case, we have a lowest price, so we have a low, and then we have a high price. Now in this case, if we were to talk about the DJ is going to cost $219 on the low end and $369 on the high end. Now, when we talk about the light show, I'm going to put LT for light. The light show costs $159 for the low end and $309 for the high end. Now, what we're looking for is a compound inequality that represents the total amount you would pay. So, total amount X, okay, so X is going to be the total amount you're going to pay. So, we're going to put X in the middle. Now, we know that we're going to do both, okay? So, I'm going to go ahead and add these up. 219 plus 159 gives me a total of $378. We're going to go ahead and bring down our X. And then 369 plus 309 gives me a total of 678. Now, this middle part is what you're going to pay. Okay, that's the total amount you're going to pay. Now, you can pay the lowest amount, which is 378, or higher. So that's going to be, the amount you pay can be equal to that, or it could be 378. So that means it would be going this way. And the highest you would make or pay would be 678 or lower. So we're going to put an inequality there. So X is between 378 and 678. It's higher than 378, lower than 678, but also equal to as well. And this right here is the answer we are looking for. This is the inequality you would create. Okay, in problem number 6, match the equation with its corresponding solution for X. Alright, we have 7 problems we're going to work. Some are going to take more than 1 step, some are going to take 2, maybe even 3 steps. Alright, so the first one we're going to do is this one right here. Notice it's 4x plus 7 equals 35. So what we're going to do is we're going to subtract the 7 from both sides. And I end up getting 4x equals 28. I'm then going to divide by 4, and x is equal to 7. So that is this answer right here. On the next problem, 4 plus x plus 2 minus 2x equals 5. Well, what we're going to do is we're going to combine like terms. Notice I have the 4 and the 2 on the same side, so that is a 6. The x and the minus 2x combine to give me minus x equals 5. Now, I have a couple of ways, or a couple of things I can do. The first thing I'm going to do is I'm going to subtract the 6 from both sides because I want to get the x by itself. The 6's are gone. I'm going to bring down the negative x equals, and 5 minus 6 is negative 1. Now, I'm going to divide both sides by negative 1, and that cancels that out, leaving me with just the x. And negative 1 divided by negative 1 is positive 1. There's your answer for the second problem. Now, the third problem, notice it's a fraction. And remember, in order to get rid of the denominator, you can go ahead and multiply by the denominator. So we're going to multiply by both sides by 5. That cancels that out. I'm going to bring down the 9 minus x. 3 times 5 is 15. Now the way this reads is 9 minus something is going to give me 15. Well, if I went ahead and subtracted 9 from both sides, the 9's cancel on the left side, bring down your negative x, equals, and 15 minus 9 is 6. Well, if you divide both sides by negative 1, that takes care of that negative, you get x is equal to a negative 6, which is the very first one. Okay, so now we've done 3 problems that all include isolating the variable by itself. Alright, so the next one we're going to do is 50 is equal to 7 minus 6. So on this problem, we're going to add the 6 because the opposite of minus is addition. So add the 6, and what you end up with is 56 equals 7x. And you have to say to yourself, 7 times something is equal to 56. And so when we divide both sides by 7, you're going to find that 7's cancel out. X is going to equal 8. So now we're down to 3 answers and 3 problems. So let's go ahead and finish the rest of these. Let's pick a different color here. Let's pick a bright red, or let's pick the green. Alright, now in this particular problem, notice we have a fraction and an addition. Well, you've got to get rid of the addition first because the fraction includes the variable. So we're going to subtract 5 from both sides. You can't see that, so let's do red. We're going to subtract 5 from both sides. And you're left with 1/3 times x equals 1. Now notice I moved the 1/3 to the side of x. Or actually I moved the x to the right side of the fraction so that it doesn't look like it's in the numerator. Now, you could divide by 1/3. Or when you multiply by a fraction, you can actually multiply by the reciprocal. So the reciprocal of 1/3 is actually 3 over 1, or just 3. So if I multiply both sides by 3, the 1/3 times the 3 cancels out. You're left with x equals, and 3 times 1 is 3, and there is your answer right there. Now, we're down to no solution and x equals 2. So let's see if one of these other two can match up with those answers. On this particular problem, I'm going to go ahead and on 2x, we're going to distribute. Actually, I'm not going to distribute. Most kids will look at this and they'll go, oh, I need to distribute right there. Well, you got to understand that this is a multiplication problem. So I'm going to get 3x plus 5 by itself. So I'm going to divide by 2 here. So if I divide by 2, those 2 cancels out. I get 3x plus 5, and 22 divided by 2 is 11. I'm going to subtract 5, and I get 3x is equal to 6. Now you can divide by 3, or more or less, you look at the problem and go 3 times something is equal to 6, and we know that something is going to be 2. So there's my answer. Now, the last problem we're going to work is this one here, and it's a little bit longer. Notice that there's a distribution here. So I'm going to go ahead and get rid of that. So I get 3x. Now this is a negative 3x, so that negative 3x, or negative 3 times x, is a minus 3x. And then negative 3 times 1 is a negative 3. And you're going to bring down the equals 3. Notice we're only distributing this part right here. Now I'm going to clean it up a little bit. So 3x minus 3x actually cancels out. And what you're left with is negative 3 equals 3. Now, ask yourself, when does negative 3 ever equal negative 3? And it never does. So that there, we can put a not equals in the middle, is your no solution, because that will never happen. The LaSalle High School senior class raised funds for an end-of-the-year cruise getaway. The city gave them a special package for the port fees and taxes. A flat fee of $1,500 for the entire class's port fees and taxes. Now, it's going to cost $367 per student to board the cruise. Now, if your class raised $16,600, how many students can attend? Well, we know that it's going to be $367 per student. So I can write 367 times X, and X is going to represent the number of students we take along. Now, we already know that they gave us $1,500, so we're going to add that $1,500. Now, we don't know how many kids that are going to attend, but we do know that we've already raised $16,600, so we can't go over that amount. We can either equal that amount or we can be less than that amount. So, we're going to put that equal to $16,600. Now that we have this equation, we're going to solve for X, and we're going to find out how many kids can attend. So the first step is we're going to subtract this 1,500 from both sides. And what you end up getting is we're going to bring down to 367X. And that's going to equal 15,100. Alright? Now the next step is we're going to divide both sides by 367. And when we do that, the 367s on the right hand side cancel out, leaving us with X, which is the number of kids that can attend. Now in this case right here, it comes out to a 41.14. 41.14. Now, there's no way we can have 0.14 of a student. That's probably someone's big toe or something like that. Now, we're going to round this down to 41, so therefore 41 kids can attend. In problem number 8, Diana invested $3,000 in a savings account for 3 years. She earned $450 in interest over the time period. What interest rate did she earn? So that's the question we are going to try to answer. We're going to try to answer what interest rate did she earn. We're going to use I equals PRT. P is the principal, I is the interest, T is the time, and R is the rate. Now that's what we're looking for. We're looking for R. So let's go ahead and plug in the information that we have. Now the interest she earned was $450, so that's the I. Her principal is how much she invested. Well, that's the $3,000. We're looking for the R, and then she did it over a time of 3 years, so that's 3. So no, remember, these are all multiplication. So the 3,000 times the R times the 3. So what we're going to do is we're going to go ahead and multiply these two because they're on the same side, and I get 450 is equal to 9,000 times the rate. We want to isolate the R, so we're going to divide both sides by 9,000. Alright, that cancels out. And then, if you were to do 450 divided by 9,000, you'd get 0.05. So her rate is 0.05 or 5%. So she has a 5% interest rate or 0.05. So if whatever answer you're looking for, if they ask for it in decimal form, you give it to them as 0.05. If they ask for it in percentage form, you change it to a percentage. The ideal width of a certain conveyor belt for a manufacturing plant is 50 inches. Conveyor belts can vary from the deal with by at most 7/32 inches. Which of the following represents the acceptable width for the conveyor belt? And check all that apply. Now, in some cases, it's best to draw a picture. Now, think about this. If you had, in the middle, the ideal weight, or width, is 50. Now, it says that conveyor belts can vary from the deal by at most 7/32 inches. Now, they don't tell you that whether it's positive or negative. It just says it can vary. That means it could vary by going more than, and it can vary by going less than. So our job is to add and subtract 7 over 32 to and from 50 inches. So if I add 50 plus 7 over 32, I would end up getting 50 and 7 over 32 inches. Now, if I were to subtract, I want to know what the least width is. So if you take 50 and you subtract 7 over 32, let's borrow one, make that 49 and 32 over 32 minus 7 over 32. So now notice this is 49 and then the 32 over 32 is actually one whole. So that really adds up to 50. So what I'm going to do is I'm going to take 32 and I'm going to subtract that 7. So I end up getting 49 and 25 over 32. So that's the smallest width that you would experience at this manufacturing company. Now, I'm going to go ahead and take this part away. Now, what the question is asking is, which of the following represents the acceptable widths of the conveyor belt? Well, we know that 50 is the middle, so it could be equal to or more than 49 and 25 over 30 seconds, or it can be as high as 50 and 77 30 seconds or less. So in this case, this would be the lowest, this would be the highest. So it can range anywhere between those two measurements. So that answer choice is right here, the third one. Now, another thing you have to consider is, if you have 50 and we're adding or subtracting the same distance, either to and from, well, the other answer choice that it could possibly be would be this one right here. Because if you do 49 and 25 30 seconds minus 50, you're going to get, and take the absolute value, you're going to get an answer of 7 over 32. And if you do the same thing with 50 over 732 minus 50, again, you take the absolute value and you'll get 7 over 32. That is why this is also another viable option. Now, in this last problem, there are 850 Douglas fir and ponderosa pine trees in a section of forest bought by Karamazov Logging Company. The company paid an average of $300 for each Douglas fir and $225 for each ponderosa pine. If the company paid $217,500 for the trees, how many of each kind did the company buy? Now, you might not realize at first, but this is actually a system of equations, because we know that if you take a Douglas fir and add the ponderosa, those two added together are going to add up to 850 trees. Now, it also tells us that it's $300 for each Douglas fir. So we're going to do 300 for each Douglas fir plus 225 for each ponderosa pine. And if I were to pay those amounts, that would add up to $217,500. Now, there's one of two ways that you can do systems. You can either do elimination or substitution. And in this case, it might be easier to do a substitution, because if we do elimination, that means I would have to multiply either the d by negative 300 or the p by negative 225. So what we're going to do is we're going to take one of these equations and I'm going to subtract p from both sides, and what I end up getting is Douglas firs equals 850 minus p. And by doing that, I now know what d equals. So I can plug that in to this equation right here. And when I do that, that p is going to take the place of the d, and I'll only have the variable of p, which stands for the ponderosa pine. So what I end up getting is 300 times 850 minus P plus the 225P equals the 217, 500. Now, if you notice, I now only have the variable P in my equation. So I'm going to go ahead and distribute here. And what I end up getting is 300 times 850 is 255,000 minus 300P. Bring down the 225P equals 217, 500. Now let's go ahead and clean it up by combining like terms. Oh, I forgot the P on that 225. So I'm going to combine these two right here. Well, what I end up getting is 255,000 minus 75P equals 217,500. Now I'm going to solve for this P, so I'm going to go ahead and subtract 255,000 from both sides. And what I end up getting, I'm going to bring down that negative 75P, and that's going to equal a negative 37,500. But when I divide, I'm going to isolate this P right here. I'm going to divide both sides by negative 75. Now remember, a negative divided by negative is a positive. So I end up getting P is equal to 500. Now out of all that work, it came out to a nice little even P equals 500. Now the question is, how many of each kind of each tree did I buy? Well, this means right here, I have 500 of the ponderosa pines. But I have a total of 850 trees. So Douglas is going to equal the 850 minus the 500. So that's going to give me 350 Douglas firs. So in that case, the answer to my problem is B, 350 Douglas firs and 500 ponderosa pines.